identities, and we've got the left hand side here is allegedly equal to the right hand side, but we need to prove this. So which side are we going to simplify, the left hand side or the right hand side? And I'll ask with a chuckle, because when the right hand side's 1, what are we going to do? We're go on a real roundabout journey to simplify this. I mean, it would be doable, but sure, you'd be maybe saying, well, let's choose a trig ratio. Is sine x over sine x, thetas at least. So maybe like sine theta over sine theta. Oh, well, wouldn't it be interesting if we multiplied this? That's ludicrous, right? So is that the name of a band or something? So let's simplify the left hand side. There's a sine cubed. I mean, that's just crying out not to be there, right? I don't know how to deal with sine, but if we can get sine squareds, then we're going to look good. So maybe I'll ask this question that I haven't even had a chance to ask yet this paper. How many terms do we have on the top? 1 term. Okay. How many terms do we have in the denominator on the bottom? 2 terms. Well, not always, but didn't it always seem so helpful that when we got fractions, we try to get 1 term over 1 term so we can start cancelling? How do you turn multiple terms? How do you manipulate multiple terms so that they become 1 term? Well, if you cheekily thought, well, I could just put brackets around it. Yes, if you can't, factorize it. So factorize. Hey, look, there's a sine theta, there's a sine theta. So for my mind, I don't know where this question is going to go, but I mean, without even thinking, sine theta I'm going to tag out as a common factor, and lo and behold, what's over here? So what do we not do that might actually have been useful to have put here for reference at the beginning? I think it would have been useful to put our fundamental trig identities. Remember, you are given a cheat sheet in this one. Oh, there it is. But you're not given any of the fundamental identities. So the first one was, we looked at tan theta and we said, cool, that's sine theta over cos theta. And then we said, oh, well, what is that other one? It was something like sine squared theta plus cos squared theta equals 1. Those are 2. Done, happy, except let's just write the 2 variations of that. So if we subtract cos squared from each side, we'll just have sine squared theta on the left, 1 minus cos squared theta. If from this second one we subtract sine squared theta, we'll be just left with cos squared theta. What you do on one side, you do on the other. So you've got them there for reference, and I would hope that they come up somewhere else in the paper, but it's worthwhile writing down. Jot them down quickly. Done. You might have done it before you even started the paper. Well, before you started the paper, that doesn't make sense. But as soon as it's, okay, reading time's up, you just jotted these down somewhere. So you got them for reference, and then we get, oh, prove, I'll use these. Or you get to this question and use it there. Anyway, I can assure you that one of them is going to get used over here. It's that one, by the way. Okay, cool. So determine the general solution of this thing that's going on here. Now, this doesn't look so pretty, and just it does look pretty. That's an awful thing to say. But what it doesn't look is that it doesn't look that immediately accessible. And what I want to caution against, because this is where we made a bit of a mistake once before, some of us, where we said, okay, well, we can divide by cos x, we can divide by cos x, and therefore we've just got 2 sine x equals minus root 3. Issue with that is that if cos x equals 0, we've gotten rid of a solution. And what's to say that cos x can't equal 0? When x is going to be, what would x equal? That's a good question. So if x is 90 or 270, then that's a fair solution. 0 equals 0. So you can't just do this. So let's cancel that idea. But it kind of is sort of an idea. because we still want to just deal with one trig ratio at a time, one trig function or ratio. Rearrange your equation. Now, how do we know to do that? Because there's nothing, we can't just divide by that, so let's rearrange it. So we got 2 sine x cos x, let's write this a bit neater, I'm rushing here. 2 sine x cos x plus root 3 cos x equals 0. I keep going on, and I love the idea of terms. We've got 2 terms. Wouldn't it be beautiful if we could turn this into 1 term equals 0? We can take out a common factor of cos x, that equals 0. When you multiply 2 things and their product is 0, hey presto, either that one's 0 or that one's going to be 0. Similar to if you were given something like 2x squared minus x equals 0, you take out a common factor and that would be 0 or that would be 0. So same idea of factorizing. Okay, and then from there, well, you'll have your 2 solutions, and remember it said general solution, so that's when we do that plus k times 360 or 360k. I can't always forget which way around I did each time. Okay, so that's the thinking behind that one. 6 marks. Marks aren't that important, are they? Except that this could take this a little bit of work to be done here. You're going to do this, you're going to find that, you're going to find the 2 solutions, then there's going to be a second one and the 2 solutions for that, and that'll be it. Okay, that's enough for this video. Let's move on to the next one in the next video.